All right, so if you guys are looking for some places to study on these types of problems, if you missed 1, 2, or 3, or you want some extra help on 1, 2, or 3, you can look on page 250. Example 2 would be an excellent place. Number 4, page 251, example 3. And if you missed number 5, really page 259 is a great place to look, and page 271. Extra help on number 6, a great place would be page 268, example 1. Alright, these answers here, 7, 8, and 9, page 263 is a great place to look, 14 through 19, those are the types of problems. Best place to look for help on number 10 is going to be page 305. Example 1 is the best place to look. It's actually 1A is the easiest. Remember, there were 2 parts to this last one. So this first part on number 11, page 312 is the best place to look for that. And then the second part, you're really looking for 313, example 2, and example 3. Alright, if you need some help on 12, page 269, example 2A is your best place to go for the factoring, and then example 5, talk about the zero product property. And on 13, your best place for the factoring is going to be 270, example A, and then once again, example 5 will help you with the zero product property. Kind of put those together. So again, square root property, page 284, example 1, and then for completing the square, page 286, example 4. All right, for 16 and 17, using the quadratic formula, you got page 293, example 1, and page 17, number 17, page 277, example 3, and you need a little bit of example 1 there too. Okay, looking at this number 18, you've got the yoga membership up here. Remember, it's $20 for 70 people last year. So you remember from last year that 70 people times $20 would tell you how much money to make, right? But of course, this year, you're going to raise the price. So what's going to happen? You're going to raise the price of the money by $1 per for every dollar, and for every dollar that you do raise it, you lose a customer, and you end up with this situation here. Okay, so it looks like it's linear, but it's really not, because you're going to FOIL this out. So what I would ask you to do is, I'm not going to do it for you, I'm just going to ask you to do this. Of course, what you would do at this point is you would multiply like FOIL. Alright, and then you're going to solve no, you're not going to solve, excuse me. You're going to find the maximum. Okay, and it's up to you how you find the maximum. You can find the vertex, you can put it in vertex form if you choose, or you can just use your formula, negative b over 2a, kind of like you did on problems number 2 and 3 and 4 on the front. Your choice on how to do that. But that's going to get you through number 18 and number 19. Okay, the actual price itself on the first one is whenever you find x here, this is the price, 20 plus x. So whatever you find for x, you can do 20 plus x, and that will be the price. Now for the maximum income, you want to do the whole thing. We'll give you your maximum income. Alright, on this second one with the soccer ball, it says it's kicked in the air and its height is modeled by this equation, and the horizontal distance is modeled by this equation. Well, guess what? On 20 and 21, I never ask you about the horizontal distance. So that was purely there just as a red herring, just to kind of throw you off. I ask you, how long is the ball in the air? you can do this in different ways, but this is what you're looking to do. It is quadratic, and if I graph it, I end up getting something that looks like this, where this represents time and this represents height. Okay? Now, my solutions are somewhere on this graph. How long is the ball in the air? Well, that's time. Okay? The ball is in the air this whole time. It's still in the air, still in the air, still in the air. What happens right here? It hits the ground. It is no longer in the air right here. So whatever this answer is right here, this answer is the answer to number 20. So I need to find the solution to 0 equals negative 4.9 t squared plus 14.7 t. So you can solve this equation in any of the 5 methods that we learned. Complete the square, quadratic formula, factor, whichever method you want to do. Looking at a graph, whichever. Personally, I GCF factored it. But if you want to do it a different way, you're welcome to do it a different way, as long as you end up with it. The last question, 21, says, what is the maximum height? I think that's pretty clear what they're asking for, right? They want the maximum height. Well, the maximum height is right there. And just like on number 2, 3, and 4 on the front, the maximum height, you can either use your calculator to compute the maximum, or you can use the formula x equals negative b over 2a, and then plug that number back in. Or, if you feel real adventuresome, I suppose you could change this to vertex form, and then you would have the vertex. Alright, I know you can't see it, but over here you've got an 8 by 12 garden? Okay. So the first thing I would ask you on this problem is, it says Grandma wants to double the workable area of her garden. Well, what is it now? It's 8 by 12, right? So, okay, I'll let you do that. Whatever it is now, that's her current area, right? She wants to double it, so what are you going to do with that? Times it by 2. Well, when you double it, whatever that is, that's your new target. That's what you want it to be. Well, it says in the problem that you're going to increase the length and the width by the same amount. So we'll call that same amount x. So I'm going to take my length, which is 8 plus x. I'm going to take my width, which is currently 12, but I'm going to add x to it. And when I multiply length times width, my new length times my new width, what do I hope to get? Whatever this was, right? Whatever the double of the area was. Well, that's my setup. Okay? This is the setup. Now, how do you find the answer from here? Well, you solve. So from here, you need to solve. And you can use any method you want. You can use the quadratic formula. You can factor. I don't know that it's factorable, but you can try it. Factor, whichever it happens to be. Okay? So, your method to choose from at that point. So, this one is 2 real numbers whose sum is negative 8. That's going to be x plus y equals negative 8. And then whose product is negative 209. That's going to be x times y equals negative 209. Now, that's a system of equations. There's a lot of methods you could choose to solve a system, like graphing, but I think substitution works the best for us here. So what I would do, and we did an example like this together in your notes, but what I would do is I would solve this for x or y. It doesn't matter. I'll say solve for x. So when you solve this for x, you'll get something right here. You're going to take whatever you get right here and plug it in right here. So I'm going to take that and I'm going to plug it in right here. So there's my new something times y has to equal negative 209. Well, at that point, guys, this equation becomes quadratic. So at that point, you're going to solve this quadratic. And once again, just like on the problem above it, whichever number this is, just like on the problem above it, it doesn't matter which method you choose to solve it. You could use quadratic formula, you could factor it, you could graph it, whichever, it's your choice. Okay? All right. You know you got that crazy ant who's stuck up on the roof, right? She's 25 feet above the roof. Thank you. It says, will she have 0, 1, or 2 chances to catch it? Explain. Now, remember, there's different ways you can do it. First off, this water bottle is being thrown with a quadratic model. Okay? So I know it is a U-shaped graph. Something like this. My question is, does it make it to 25? So, if the maximum is bigger than 25, then I'll know if she has 0, 1, or 2 chances. If it's exactly 25, she'll have 1 chance. If it's more than 25, she'll get 2 chances, once on the way up and once on the way down. And of course, if it doesn't make it, then she has 0 chances. So that's really what we're looking at. You're either that's 25, or that's 25, or that's 25. So that's what we're trying to look at. You can also just use the discriminant. For 25, once again, you're looking at this situation. Talk to me. If she can catch it, how high is it when she catches it? If she catches it, how high is it going to be? It's going to be 25 feet off the ground, right? If she catches it on the way up, it will be 25. And the answer, by the way, is that she can catch it. You know that. So, you know she can catch it. Oh, that's a horrible graph. I'm sorry. You know that right here is 25 feet and right here is 25 feet. So what you want to do is you want to say, hey, when does her function, when is this function equal to 25? So you're basically solving this equation. Now at this point, it's up to you how you solve it. Quadratic formula, complete the square, graph it, doesn't matter. But at this point, you're just going to solve. And you do end up with 2 answers. For the domain and the range, looking back at this graph up here, the only domain that would make sense is when the water bottle's in the air. So this is going to be the domain that makes sense. I don't care about any time after it hits the ground because then I'm pretty much over with the problem. Same thing on the range. The range is going to be whatever numbers this makes sense with. Okay? It doesn't make sense for me to talk about being way up here at 1,000 because she's not going to throw it 1,000 feet in the air. So basically from her maximum height down to 0, it doesn't make sense to talk about less than 0 because it's not like that water bottle is going to go underground. All right. If you've got any questions, that should get you through most of the test. You're going to have to look up that last page. All right. These we did as bell ringers, so you might want to look in your notes. Or if you want to go online and look up simplify radicals. Okay? It's not really a section in your book. Now these were a section. They were the complex numbers section. We didn't play around with it a lot, but basically you're looking at page 276. Examples 1 and 2, I guess, really. All right.